Hi there, Michael here. My original plan for this week's video was a first look tutorial of a spectacular new immersive audio software that was scheduled to be released this week. Unfortunately, that got delayed for a week or two. Now, I have been hinting at that video for a while, so if you have been waiting for that, my apologies. But fear not, that video is coming soon, so make sure to be subscribed. The video will most likely not follow my regular posting schedule, so you might also want to hit that notification bell. So instead of that, I thought I'd do a quick tutorial covering one of the most requested topics on my channel, Eclipse Audio. What I want to do today is go through how to set up the Eclipse Audio plugins in Reaper and how to get started creating audio in the IAMF format, which stands for Immersive Audio Model and Formats. Format, slightly weird name, not sure who came up with that. I have so far resisted covering that topic, mainly because I'm not the biggest fan of Eclipse Audio. There are a couple of things I take issue with. First, it is heavily promoted as an alternative to Dolby Atmos. Some have even called it the Atmos killer. But that is actually only partly true. In reality, Eclipse Audio has very few similarities to Dolby Atmos. The only thing these two formats have in common is that they both transport immersive audio. But this, quite honestly, is where the similarities end. In contrast to the object-oriented approach Dolby Atmos takes, Eclipse Audio is purely a channel-based format. Actually, it's more of a container format that holds channel-based audio. In Eclipse, you do have the concept of audio elements, and we're going to go over that a little bit later in this video. But the Eclipse Audio elements have nothing to do with an object-based audio format. So if you're expecting something similar to Atmos objects, you will get confused pretty much immediately. The philosophy behind Eclipse Audio is actually a lot closer to MPEG-H than to Dolby Atmos. And the second major issue is that while the format is being heavily promoted, its use is still very limited. Yes, YouTube accepts Eclipse Audio in YouTube videos, but at least in my understanding, if you are not watching YouTube on specific Samsung TVs, you are not really getting an immersive experience. Rather, it's just rendered either in stereo or binaurally. And the reason I'm not even sure about that is that the documentation is practically non-existent. In fact, in the following video, I will come across a question that I'm not going to be able to answer because no manual I could find had the information I needed. And I could not test it out because I currently have no way of playing back Eclipse Audio in a fully immersive audio setup. I can listen to it on YouTube in stereo, but that did not give me the answer I would have needed. So with these huge caveats in mind, let's jump into Reaper and set up an Eclipse Audio session. Now, I know that a lot of you out there are passionate about this format, so I promise that I'm not going to hit on it too hard. But to be perfectly honest, that's going to be really difficult because there are so many things in Eclipse Audio that feel very half-baked. So with that being said, let's jump into it. So here I have a very simple Reaper session with 4 tracks, and if you've been watching my channel for a while, you already know these tracks. It's something that I like to use a lot because it doesn't trigger any copyright issues. So let's just have a brief listen what we have here. So essentially we have a kick track, a bass track, a synth track and a piano track. And what we're going to do is we're going to turn that into an Eclipse Audio session. Now, the first thing that you obviously have to do is you have to download the Eclipse Audio plugins. Fortunately, these plugins are completely free. I'm going to leave a link in the description below. You can simply go to the website and download it and install it. And it should work on your machine, regardless if you have Windows or Mac OS. Now, these plugins only work with a limited number of digital audio workstations, so you need either Pro Tools or Reaper. There are a couple of things, and they're continuously testing that out. And by the time you're watching that, it might work for other digital audio workstations, but most likely you will be limited to either Reaper or Pro Tools or possibly also DaVinci Resolve, because Eclipse Audio is a format that really is targeting more the video and film production crowd. But I have Reaper here, so the first thing that I'm going to do is I'm going to add an additional track that will hold the Eclipse Audio renderer. Now, you could put that renderer on the master track, but I found it easier if we just put it on a separate track, so that's what I'm going to do. So let's add a new track here. And on this track, let's first call that Eclipse renderer. Eclipse renderer. And here we go. And then what we're going to do is we're going to add an instance of the Eclipse renderer. So we have here the Eclipse Audio renderer, add, and that should open up the Eclipse Audio renderer. Now, before we do anything, let's go over the interface very, very quickly. On the left side here, you have a three-dimensional view of your audio scene, and you can look at it in different perspectives. You can have the top view, the side view, the rear view, or the isometric view. And then you can also turn on the visibility of the speakers. In my particular case, I currently have a speaker setup that is stereo. This is because I'm recording that in stereo so that I could put it out on YouTube. I can also kind of visualize the tracks. Currently, I don't have any, so I'm going to simply turn it off. I also have the settings for the export, and we're going to go over that towards the end of this video. And then here on the right side, we have first of all the loudness measurings, and the loudness is measured depending on your speaker setup. So if you change that over to 7.1, for example, you see the loudness measurements here in 7.1. Now, one thing that the people behind Eclipse Audio constantly point out is that Eclipse Audio is a what you see is what you hear approach. So when you turn that speaker setup to 7.1, the impression that you get is exactly the same that somebody would get who would play that back on the 7.1 speaker setup. Now, that sounds trivial, but that's actually not always the case. In Dolby Atmos in particular, there can actually be quite a difference in what you hear in your studio and what people hear on their consumer software or consumer hardware. And in Eclipse Audio, this is not the case. So what you hear, what you see is what you hear. What essentially you get here is exactly what the consumer would get on their devices as well. So let's turn that back to stereo because that's really all that we have here. And then down here we have the mix presentations, and that's actually the first thing that we need to set up. In Eclipse Audio, you have the concept of mix presentations. Now, what are these mix presentations? Now, the basic idea behind that is that if you are producing audio for film and TV, for example, what you sometimes will have is you will have different language tracks, for example. So you might have the video or the film or the TV series or whatever in English, and then you will have it in Spanish, and you would like the viewer give the opportunity to actually switch between those. And for these, you can use mixed presentations. So you could have a mixed presentation that presents everything in English, and you could have a mixed presentation that presents everything in Spanish or in French or in German or any other language, and then the viewer could simply switch between those. Now, this is the basic purpose of these mixed presentations, but they could also be used for other purposes as well. So, for example, in music production, you could have a clean mixed presentation and an explicit mixed presentation. These are all things that you can do with those mixed presentations. Now, before we can set up the mixed presentations, we first need to define how the Eclipse Audio session is actually constructed. And for that, we need to define what audio elements are in the Eclipse Audio session. And an audio element is really a piece of audio that is then mixed in the mixed presentation. And if you think that sounds an awful lot like Dolby Atmos, that is understandable, but you would be completely wrong. Essentially, there's a fundamental difference. In the Eclipse Audio, audio elements are really things that are played on top of each other. So they are not really like an object that you would kind of move around in three-dimensional space and then kind of mix into with the rest of the objects. In Eclipse Audio, these are really two separate things that are mixed on top of each other. So once again, example, in a film production, you have the ambient sound and then you have the narration, for example, and then you put the narration on top of the ambience, but you're not really mixing that in a traditional sense, if that makes sense. And for that, we need to define what the audio elements actually are. And in order to do that, we need to click here on the reroute button, and that gets us into the routing setup. Now, the first thing that we need to define is we need to define what profile we want to use for Eclipse Audio. Eclipse Audio has different types of profiles. If you've ever worked with MPEG-H, you're familiar with that concept, and that's basically the idea that you have a very flexible format that can have different complexities depending on what you're using it for. And currently Eclipse Audio has essentially three different profiles. One is called simple, one is bass, and what's its bass enhanced. And these profiles differ in the number of channels they can support, in the number of audio elements they can support. Now, most of you are probably going to use the bass format. The bass format is the one that YouTube supports, so that's actually the one that's probably most useful for you. And the bass format has a total of 18 channels, and we're going to come back to that in a second, and a maximum of 2 audio elements. Now you might wonder, well, 2 audio elements, that's not really a lot. What can I do with 2 audio elements? And that is completely true, but to be perfectly honest, for most applications, that is perfectly fine. So what you would normally do with these audio elements, for example, is that you would have an immersive environment in your video, for example, if you're doing a 360 video, and then you would have a narration, and that narration would be headlocked. So you could have like the 3-dimensional ambient environment as one audio element, and then the headlocked narration as a second audio element. And that's actually exactly the way we're going to set that up. So for that, let's add an audio element. And the first audio element that I'm going to add is the immersive part of my Eclipsa audio session. And there are a couple of different options that I have. I could choose a channel-based format, so I could choose anything from mono up to 7.1.4. Now, in theory, Eclipsa Audio supports much more than that, but the Eclipsa Audio Renderer, the way it is implemented right now, supports those options. Now, be aware that if you're choosing a channel-based format, then the way it is played back on a consumer system is not necessarily the way you expect it to be played back. So for example, if you're choosing your audio element to be 5.1, and then this 5.1 file is played back on a 7.1 system, it's not that the Eclipsa Audio Renderer is upscaling that or kind of bringing kind of the additional 2 channels in and mixing them in or some way. It's actually going to just use the 5.1 channels that are in the 5.1. It's going to ignore the other 2. So be aware that it does not upscale in the way you would expect it to upscale. So if you want to be really fully immersive, my recommendation would be to go with one of the scene-based channel formats, and that would be one of the ambisonics formats. So what we are going to do is we are actually going to use a third-order ambisonics format. This third-order ambisonics takes up 16 channels. We have a total of 18 channels. So if we are using a 16-channel third-order ambisonics and then a 2-channel headlocked stereo, that's actually all we need, and that's what YouTube with the base format supports. So let's do that. So we're going to add a third-order ambisonics audio element. Now we could give it a name, but we already know it's going to be third-order ambisonics. And then what we're going to do is we're going to add a second audio element, and we already see that we only have 2 remaining channels available to us. So in the base format, we have a total of 18 channels. So we're going to add one more audio element, and that's going to be a stereo element. And now we have the elements defined, and we can go back into the main interface and define or edit our mix presentations. Now, in my particular case, I'm just going to use one mix presentation because that's really all I need for this particular setup. So what I'm going to do is I'm going to add the third order ambisonics as one element and then the stereo as another element. So in my mix presentation, I just have the 2 elements that are just defined, and I could kind of create additional mix presentations, but for the purpose of this tutorial, I'm not going to do that. So if I now go back, I see my mix presentation containing of the third order ambisonics and the stereo, and this concludes the setup in the Eclipsa Audio Renderer. So what we now need to do is we need to bring the audio into the Eclipsa Renderer, and this is done by traditionally routing it to the corresponding channels in the Eclipsa Audio Renderer. Now, if you look at the interface here, you see that the Eclipsa Audio Renderer expects the third order ambisonics file coming in at channels 1 through 16 and the stereo at channels 17 and 18. And this is exactly what we need to do. So the first thing that we're going to do for that is we need to change that track that the Eclipsa Audio Renderer sits on to an 18-channel track, because otherwise we are not going to be able to get these channels in. So let's just switch that over. So we're going to send that to 18 channels. Now, the channel recommendation is to set it to the maximum number of channels that you can use in Eclipsa Audio, and that would be 28. So if you're going with the enhanced base profile, you can use up to 28 channels. Now, if you want to be super safe, you can do that. But in our case, we are only going to work with the base profile. So 18 channels is really all that we need. So let's close that again. And then we need to route our audio tracks into the Eclipsa Audio Renderer. And I'm going to, first of all, mute everything but the drum track, because that's the only one that I need. So the first thing that I need to do for that is I need to put an Eclipsa Audio element plugin here. And so let me just add an element. So that is sort of almost like, kind of like if you ever worked with the Fiedler audio system, like the Beam plugin, well, not exactly, but sort of similar. Or if you're working in Dolby Atmos traditionally, it would be like the Music Penner kind of, sort of. So it is the one plugin that tells the renderer, hey, here is one track that actually belongs to your Eclipse Audio session. So we're going to add an Eclipse Audio element plugin here. So let's add that. And what we're going to do is we're going to take the drums and we are going to route that into our ambient sound environment. So the first thing that we need to do is we need to kind of tell the element plugin which audio element this track belongs to. Now, this is simply done by kind of selecting here. Once again, I have two. That's all I can have. I have the third order ambisonics element and I have the stereo element. And we are obviously going to add that to the third order ambisonics element. As soon as I do that, I see additional information about the loudness of that track. And if you're using third order ambisonics, you actually see kind of a visualization of the energy distribution of the third order ambisonics file. Now, there are two ways on how we can use the element plugin. The first one is in pass-through mode. And what this pass-through mode does is it just kind of passes the audio through and just tells the renderer that there is some audio, gives him some additional information, but it doesn't really do anything else. Now, what you can do is you can enable the panning controls, and what this will do is that it will give you a panner that will allow you to pan this element or this audio track into the corresponding immersive element. Now, this is a panner that you can use. It's a very limited panner, but it might be enough for most of applications that you have. And a little bit later in this video, I'm going to show you how you can actually use a different panner for Eclipse Audio so that you're not relying on that very, very simple panner here. But this panner has all the things that you would normally need. You can position the audio left, right, kind of front, back, up, down, and then you have additional kind of possibilities to make your life a little bit easier by having these kind of limitations where the position of the audio object is following certain surfaces in your three-dimensional space. We are not going to use that. It's not going to be particularly useful for us. So let me just put that back here. Okay, here we go. And now the next thing that we need to do is we need to make sure that the audio actually reaches the renderer. And this is done by traditional routing through the routing system that your digital audio workstation has. So what we have is, or what we need to do is we need to turn the track into a 16-channel track because we're dealing with third order ambisonics. And then we need to route these 16 channels into the first 16 channels of the track that holds the Eclipse Audio renderer. So very simple. So we're going to go in here and we're going to first of all switch that over to a 16-channel track. And then we're going to not send that to the master because we only want to send that into the Eclipse Audio renderer. So we're going to add an additional send, and that's going to send into the Eclipse renderer. And in the Eclipse renderer, what we want to do is we want to actually send the entire kind of 16 channels in there, and that will now send everything into the Eclipse Audio renderer. And if I now play the audio, I should already hear something. So let's see if I did everything correctly. I can now kind of see the track, and let me just go back here. There's something slightly weird going on, so let me kind of move that around a little. Okay, here we go. Now, one thing that you need to be aware is that these plugins are still in development, so they have a couple of, let's call it quirks. So sometimes it doesn't do what you want it to do. So for some reason it got set on the right side, but yeah, that's fine. And let's put that, maybe if you can put that back and up a little, and then we should actually see in the Eclipse Audio renderer the position of that object. So what you need to do now is you need to simply route all your tracks into the Eclipse Audio renderer, and we are going to do that in 3 different ways. The first one we're going to route in exactly the same way we routed the drums track. So with the Eclipse Audio Elements plugin being the panning device, then we're going to route the synth track with a different panning device. We're going to actually use the Audio Brewer's panner for that purpose, and then we're going to route the piano track into the second element to just kind of check out how that works. So let's go. So the first thing that I'm going to do is I'm going to close that here, and let me first of all unmute the bass track here, and let's add an Eclipse Audio Element plugin. And we're going to do exactly the same thing that we did for the drums. So we're going to route that into the third order ambisonics element. We're going to enable the panning controls, and then we are going to, let me close that here again, we're going to set up the track. We're going to turn that into 16 channels, disable the master send because we're just sending it into the Eclipse Audio renderer, and we're going to add the additional send here into the Eclipse Audio renderer where we have all 16 channels sent into the 16 channels of the Eclipse Audio renderer. And let's just play that. And then I can do the same thing that I did with the drums track. So let me just wait until the bass comes in again. Let's put that to the front. And we should see that in the Eclipse Audio renderer. So that's actually in the back. So we have the speakers here and we have the bass here is in the back. That's fine. For the purpose of this tutorial, that's perfectly fine. Oops. So let's do that one more time, and for that I'm going to use the synth track. So once again, I'm going to unmute that. I'm going to add the Eclipse Audio Element plugin, and this time I'm actually going to leave it in pass-through mode. I'm just going to switch that over to third order ambisonics, and instead of using the panning device or the panning controls in the Eclipse Audio Element plugin, I'm actually going to add an additional panner, and for that purpose, well, let me just first change the track layout. So we're going to change that over to a 16 channel track. We're going to disable the master send. We're going to add a new send into the Eclipse renderer. We're going to make sure that all 16 channels are sent over, and that should kind of take care of that. And then what we're going to do is we're going to add an additional renderer, and I'm going to use the Audio Brewers encoder. Let me just add that here, and here's the Audio Brewers encoder. All you really need is an encoder that encodes stereo in third order ambisonics. You can use Audio Brewers, you can use the IEM plugins, you can use the Sparta plugins, whatever kind of works for you. You can use that. Just make sure that the ordering of the channels in the third order ambisonics is correct. Otherwise, everything should work just fine. We just need to make sure that the encoder is in front of the Eclipse Audio Element plugin. Otherwise, we are not going to get the correct impression. And then let's just play and let's see. And I can move that around. And if I now look into Eclipse Audio Element plugin, I still have the visualization here, but I don't have the panning controls. The panning controls are now in the AB encoder. So if I move that around, I see sort of these the energy coming from a different location. And obviously, if I now open the Eclipse Audio renderer, I will see that accordingly in the Eclipse Audio renderer. Now, because I'm actually not using the panning controls, it's sort of located here in the listener position, but kind of that's the way essentially it is represented in the renderer. But we see that kind of all the third order MBX channels are coming in and everything works fine. So the last thing that we're going to do is we're going to take the remaining track and we're going to send that into the second audio element. Now the second audio element is a stereo element, so I'm going to leave the track a stereo track and I'm going to just add an instance of the element plugin here. So let me just add the Eclipse Audio Element plugin. I'm going to leave that in stereo. I'm going to, just for the purpose of simplicity, I'm going to enable the panning controls and I'm going to add that to the stereo element. So I've now added that to the stereo element. I can use these panning devices or these panning controls for panning the audio around. Now the way the panning works in the Eclipse Audio Element plugin is that it assumes that this is actually a mono track and it's going to position that audio object as a mono object. So be aware of that. If you want to really pan it in a more traditional way, you would have to have a separate panner to do that. But for the purpose of this tutorial, that is perfectly fine. So that's everything that we're going to use here. And then we just need to make sure that the routing is correct. And if you remember correctly, the Eclipse Audio renderer is expecting this stereo signal coming in at channels 17 and 18. So the first thing that we need to do is in the routing section, well, first of all, disable the master send, and then we're going to add a new send. We're going to send that into the Eclipse Audio renderer plugin. So the audio, those are the first two channels, is going to be sent into 17 and 18. 18. So that's the first thing that we need to do. There's one additional step that we need to set, and that is because the Eclipse audio element itself is actually sending out these two stereo channels on channel 17 and 18. And the idea obviously is that you could simply create that, or you could turn that into an 18 channel track and then simply forward these 18 channels into the Eclipse audio renderer. But what I'm going to do is I'm simply going to change the routing here in the Eclipse audio element plugin. So instead of sending that into output 1 and 2, I'm actually going to send that into output 17 and 18, and that should take care of that. So now the output 17 and output 18 from the plugin are going to be routed in track channels 1 and 2, and here in the routing section, we actually routed then these two tracks into 17 and 18 again in the Eclipse audio renderer, and that should be everything that we need to do. So let's see. Well, I need to unmute that obviously, otherwise it's not going to play. So let's open up the Eclipse audio renderer and let's see if that's coming in. And we see here at channel 17 and 18, the piano is now coming in as well. Now, this is obviously not the traditional way how you would use the second element. Once again, the traditional way would be to use that, for example, for narration. So you have headlocked audio in a YouTube video that otherwise is fully immersive, and that is something that I think would be very useful. The only problem that I ran into is that I'm honestly not entirely sure if that stereo element is headlocked or not. Meaning that I'm not entirely sure that if in the final output, if I play that, the stereo would always come in at left and right channel, regardless of how I move my head in a virtual reality environment, for example. So if it's really actually locked to my head, or if it's spatialized, meaning that it just kind of plays back as if it would be left and right channel in a kind of setup, in an audio setup. Now, I went through the manuals and I couldn't really find out, or couldn't really figure out if it is headlocked or not. Some indication is that it isn't headlocked, that it's spatialized, but if you actually look into the code, there is some documentation inside the code that seems to indicate that by default this is actually meant to be headlocked. The problem is I couldn't really test that out because I don't have any playback device that would allow me to actually test that. So if somebody has more information about that, let me know. It is true that Eclipse Audio supports that. That is actually one of the things that it specifically says, that if you have a virtual reality environment and you need a situation, or you are in a situation where you need headlocked audio, Eclipse Audio can do that. So you can switch that on or off depending on how you want to do that. But the plugins don't give you that option, or at least I didn't see that option, and I'm not quite sure what the default is. So it could very well be that this is headlocked or it is not headlocked. We will see. But in theory, at least, Eclipse Audio supports that. So if in the future we will be able to actually experience that in a fully immersive way, we can test it out if it is headlocked or not. And if one of you knows more about that, let me know in the comments. I'm really curious. I tried to kind of ask a couple of people. I wouldn't get any answer to that. So if you know that answer, let me know in the comment section, and I can essentially make another video about it. So this leaves us just one thing to do, and that is to export everything as an IAMF file. And to do that is actually really simple in Reaper, because we can use the regular bouncing in Reaper. But we need to set everything up, and for that we go here into the export section of the Eclipse Audio renderer. We enable export audio. We need to give it a name. Now I've already done that because I ran a test before. So I can simply say test here, and I'm going to save that as a test here. I can select which format I want to save that to, IAMF or WAV, and I can also select the codec. Now my understanding is that if you want to use it for YouTube, you need to use the Opus codec, but I'm not entirely sure. I will make a separate video about that where we clarify that. But for the moment being, we just leave everything the way it is. And then you don't need to set start and end time, because we are just going to use the regular Reaper bounce. The one thing that's also interesting is you could technically already mux a video. So if you are creating a YouTube video, for example, you would specify that video source here and then the Eclipse Audio renderer would give you a new version of your video with Eclipse Audio instead of your regular audio. And that is really super useful. I think that's something that a lot of people will want to use in the future once Eclipse Audio is fully supported through YouTube. But for the moment being, I'm just going to leave that the way it is. And then I'm simply going to export everything. And the way this is done is simply by going to the bounce section here. So we're going to render everything. And we're going to render this one file. I'm going to render it onto the desktop. That's going to render that. By default, it's also generating WAV files for each audio element. And that means that I now have a Ambisonics WAV file for the Ambisonics part, for the Ambisonics element, and the stereo WAV file for the stereo element. Now it takes a little bit until it has the export completed. So let's just wait until that is finished. But it should actually finish relatively soon. And here I think we already go here. Here we are. So we have the test IAMF file that I cannot play on anything because I don't have any device that could play that. And I have the first element, which once again is a 16-channel Ambisonics file, and the second element, or element 0 and element 1, the second element that is a stereo file. And I can use those if I want to, but kind of in theory, what you would normally do is you would mux that into a video and just export it to YouTube. So what's my final verdict? Well, let me put it that way. If you don't mind that there is virtually no documentation that can help you, the plugins are still very much in beta and do certain things in ways that I did not really expect them to do. There's a bit of a questionable usability. There are certain choices that are made in these plugins that I was not quite sure why they are visualized the way they are visualized. And most importantly, whatever you're creating, you're most likely not going to be able to play that back in a very immersive setup. So if you don't mind all of that, this is a great format. But I have to be perfectly honest. I think if this ever becomes standard in YouTube and you could actually create Eclipse Audio in a way that would be fully immersive in a YouTube video, so that I can, for example, use my Apple AirPods and then listen to YouTube in a fully immersive way with headlocked audio. If that ever becomes a reality, and my understanding is that that's what they're aiming for, then this could actually really become a really, really cool format, because it is technically really easy to do once you know what you're doing. And it allows you to directly mux that into videos, and that is super convenient. So if that ever happens, then yes, I'm super excited about that. But at the moment, it is a little bit of a hit and miss. It's a little bit of a beta everywhere. Well, that's everything for today. If you have any questions, drop them in the comments or join a free Discord server. The invite link is in the description below. And don't forget to subscribe to stay updated on all things Dolby Atmos and immersive audio. Thanks again for watching, and I'll see you all in the next video.